Hello everyone, in this presentation we will represent another example of isotopes. Now we all know that an element is a substance made from one type of atom and cannot be broken down into any simpler substance, and it has a unique atomic number. This means that all atoms of any particle element must have the same number of protons, since the atomic number is the number of protons, and the number of electrons as well, since atoms are electrically neutral. The number of protons equals the number of electrons. For example, the atomic number of hydrogen is 1. Any atom of hydrogen will have one proton only, otherwise it wouldn't be a hydrogen. If an atom has 2 protons, then it would be helium, since the atomic number of helium is 2. So, an atomic number of a particle element cannot change. However, the number of neutrons inside the nucleus can change. In fact, there are 3 types of hydrogen atoms, each containing a different number of neutrons. So these are the isotopes of hydrogen. Isotopes are atoms of the same element, so they have the same atomic number but different mass number. Since they have a different number of neutrons, let's examine together the isotopes of hydrogen. So these are the 3 different atoms of the same element, hydrogen. How did we figure out that they're of the same element? Since Z of each one of them is 1, so the element is hydrogen. However, they have different mass number A. Let's fill this table together to show the number of protons, electrons, and neutrons in each isotope of hydrogen. We'll start with the first one. The red circle represents a proton, while the green circle represents the neutron. Now pause this video for a minute and try to fill this table by yourself. Well, in the first case, we have 1 proton and 1 electron, since it's a neutral atom. And as you can see, it has no neutrons inside the nucleus, so it has 0 neutrons. Actually, even though we're not provided with a figure, we can determine the numbers. So this subscript over here represents the atomic number, which is equal to the number of protons, and the number of electrons as well, since it's a neutral atom. So we have 1 proton and 1 electron, and the superscript right here represents the mass number, which is equals to Z plus N. So Z plus N, 1 plus 0, will be equals to 1. And if we have only 1 proton, then the number of neutrons will be 0. If we examine the second atom, we will find that it has 1 proton and 1 electron, so the atomic number will be equal to 1. However, it has 1 neutron inside its nucleus, and the last one has 1 proton and 1 electron as well, but here we have 2 neutrons. So these are the 3 isotopes of hydrogen. Since they have the same atomic number Z, which is 1, but different neutrons inside the nucleus, and thus they will have a different mass number. Let's find out which statement is true about the isotopes of hydrogen. They have the same number of protons, neutrons, and electrons. They have the same number of protons and the neutrons, but a different number of electrons, or they have the same number of protons and electrons, but a different number of neutrons. If we examine the figure in the table, we will see that they have the same number of protons and electrons, but different number of neutrons. So it's the third choice that's true. And here's the definition of isotopes. They have the same number of protons and electrons, but different number of neutrons. The chemical properties are usually determined by the number of electrons of the element. And since isotopes have the same number of electrons, then isotopes of an element will undergo the same chemical reaction. The only difference is in their masses. One way of writing the number of an isotope is to write the name of an element, followed by the mass number. So these are the 3 isotopes of hydrogen: hydrogen 1, hydrogen 2, and hydrogen 3. This one means that it has a mass number 1, the second one has a mass number 2, and the third has a mass number 3. Thanks for watching.